Hello everyone. My name is Sinarjunan Prasetyaji Arianto. I'm here to present to you the telecommunication system in Iron Dome. So, the Iron Dome is a real-world application use of high-tech system, and since 2011, Iron Dome has intercepted thousands of rockets with a reported success rate over 90%. So Iron Dome is a multi-component coordination in milliseconds. Every interceptions depend on rapid communication between radar, control center, launcher unit, highlighting the importance of telecommunication engineering. And there's the data link in Iron Dome is consists of radar, BMC, launcher, and interceptor. So next. So the telecommunication system that used in Iron Dome is first data collection and transmission from radar to BMC, the battle management control. So the next one is decision making and command dispatch from the BMC to launchers. Next one is missile guidance communications, which from BMC and radar to interceptors, and telemetry and post-event feedback. So I will explain you about the data collection and transmission. This which happened where in radar to BMC. So the radar, which is the EL/M2084, it detects and tracks multiple airborne targets. It calculates speeds, altitude, trajectory, and impact zone. This data is encoded and transmitted via secure radio communication, or UHF or VHF, which is the ultra high frequency or very high frequency. Also, it can be sent from tactical radios or microwave links. And also, it can be sent by fiber optic links. And the data is transmitted in real time, so there's no delay, very low delay, which is below 1 second latency to the BMC system. So the next one is decision making and this command dispatch. So this happened in BMC to launchers. The BMC process all incoming data from using an embedded AI algorithm, rule-based threat analysis. So it performs threat prioritization. So example, a simple one. Well, there's one rocket heading to empty field, and there's one rocket heading to a city. So the one that heading to empty field will be ignored, and the one heading to a city will be intercepted. And then once a threat is validated, the BMC select the closest or most optimal launchers, then sends a launch authorization package. So it consists of target coordinates, velocity vectors. It will be sent via encrypted data links, which is the radio or microwave, high frequency radio waves, or satellite communication or fiber if it's available. So the next one is the missile guidance communications, which happen on radar and BMC to interceptors. So after launch, the Tamir interceptors missiles receive mid-course updates from the ground radar. These updates are transmitted via uplink telemetry data links. It used to correct trajectory mid-air for precision targeting. So it's used a two-way communication that allow the interceptors to send back its positions, also adjust flight path using a common uplinks. So the next one is telemetry and post-event feedback. So the telemetry is automatic measurements and wireless transmission of data from a remote device to a receiving system. So after the interceptions, the system transmits kill confirmations and flight data logs. These are logged and transmitted back to Central Command for performance analysis and machine learning training. So there are features in this telecommunication system on Iron Domes. One of them is an inscriptions. Of course, like any military system, other military system, it's used encryption. The purpose is all the data links are encrypted using a military grade standard for security. So the second is frequency agility. So the purpose of this is using a frequency hopping or spread spectrum to resist signal jamming, and redundancy, which is the multiple communication paths to prevent a single point of failure. And of course, as I said before, is low latency, which is the end-to-end command chains complete in under 2 until 3 seconds, and often less because it says real time. And the last one is network centric, integrate into Israel's multi-tier missile defense, communicating with system via secure links. So the conclusion of role of the telecommunication in Iron Dome, it's enable real-time detection and decision making and coordinations. And the second one is this system highlights how modern warfare and defense are driven by information network as much as physical hardware. This case proved that telecommunication engineers play a critical role in national defense and security. And the last one is the key part. Without telecom, the Iron Dome is just a set of isolated parts, isolated system. With telecom, it's become a one intelligence coordinated defense network. So thank you for listening my presentation. Goodbye.